Now there's another way we can apply these rules. If you have the right-hand side, then you can get the left-hand side, right? Either of these. Okay? So let's take log of x plus 5 times the log of y. Okay? So is there anything there that you could apply one of these rules to? Well, you don't have a log of a to the b, you don't have a log of a times b. You got a log of something plus something like another log, but it's not a log of x plus log of y. You got that 5 in front, right? The rule doesn't apply if you got a number in front of this, okay? But the rule does apply to just this circled part, because that's this. You got a number times a log of something, right? So you have this here, so this can be simplified. And that becomes the log of y to the 5th. 5 times the log of y is a log of y raised to the 5th. Okay? And you still have your log of x, but now you have a log of something plus a log of something else. Well, that's this. And it can be written as the log of the product of those things. So it's a log of x plus log of y to the 5th is a log of x times y to the 5th. Very straightforward. But you got to get used to it. You got to see it both ways. So really only 2 laws, but some people will want a third law if you don't understand negative exponents as well as I hope you do. So we're going to look at how we might solve this equation. Now actually the easiest way to solve this equation is do 10 to this side equals 10 raised to this side. Okay? You just use the inverse function. Okay? Apply the inverse function 10 to the x to both sides. That's not what we're going to do. I want to illustrate how you can use logarithms here. But then we're going to solve it the other way, and you'll see it comes out the same. Okay, so this can easily be rearranged to this. We just subtract this from both sides, subtract this from both sides, and we get our logs on the same side, right? Now, if I had a plus here, then I could apply this rule up here, right? Log of something plus a log of something, better a log of something minus a log of something. What are we going to do about that? Well, there's a third rule if you want to remember it, and most of you probably will. But we don't need the third rule. So if you want to be really clever and just know 2 rules, that's okay. Okay? The third rule is not particularly difficult. It seems sort of natural once you get used to it. Okay, well, the way I'm going to do this, though, is I've got a log of something minus something, but I've only got a rule for a sum of 2 logs, right? Well, I can make that into a sum. Log of something minus something is something plus -1 times that other something, right? Well, now, of course, I can't just add these because I've got a number out in front. What do we do with the number out in front? Well, we apply this, right? We got -1 times the log of something. That's going to be the log of that something to the -1 power. Because it's, the multiplier becomes the power. So, what's the something? Well, it's a log of 3x plus 5. So that -1 is going to become the power of 3x plus 5. It's going to be 3x plus 5 to the -1. And now I have a sum of 2 logs, right? Now, before I apply the rule, I'm going to write 3x plus 5 to the -1 as 1 over 3x plus 5. Didn't have to do that, but I'm going to have to eventually, so I went ahead and did it here. So now I can say, well, okay, now I've got the log of one thing plus log of another, and I can do this, log of that first thing times the log of the second thing. Okay? And then everything becomes very easy. Okay, I have the log then. Well, first of all, x times 1 over 3x plus 5 is x over 3x plus 5. Okay? If you don't understand why that's x over 3x plus 5, I did give an explanation in the MCR, but I'm not going to mention it here. We need to know this. Okay? But if you don't understand, just look for that video. Okay? So we have the log of x over 3x plus 5 equals -4. Well, now we have a log of something equals something else. It's a base 10 log, so we put it in exponential form. 10 to this power equals this. In other words, this is going to be 10 to the -4th. And there's just 3 dots here. Now, one of the dots is you multiply both sides by 3x plus 5, because that's a denominator, right? Something you automatically do, just like you automatically observe whether you have a quadratic equation. Okay? Things that people tend to overlook, and if you overlook them, you're pretty much dead in the water. Okay? So you just got to get those principles down for equation solving. Okay? Anyhow, that's easily solved. I just have et cetera there. Everybody can solve that. Okay? Now the other way of solving it, and another rule. Here's another rule if you want to use it. I'm not going to circle it in red because it's not a necessary rule, but it can be handy, so if you want to remember it, I'm okay with that. It says log of A minus log of B is a log of A divided by B. Now, I said why here. It's because the log of A minus the log of B is log of A plus -1 times the log of B. And that gives you the log of B to the -1. So now you have the log of A plus the log of 1 over B, which is log of A times 1 over B, which is a log of A over B. So a very simple rule, very simple reason that rule applies, and it's just a combination of the 2 rules that I've given you, okay? Still, it's a handy rule to have, and I'm okay. As long as you got the rules, know how to apply them, I'm just happy as a lark, okay? I mentioned the connections because I think it's easier to remember them if you understand how everything is connected, okay? Now, I proceed then to solve the same equation by applying the inverse function, the 10 to the x function, to both sides. So I get log x plus 4, log of 3x plus 5, okay? I do 10 raised to log x plus 4, 10 raised to the log of 3x plus 5. Well, 10 to the log of 3x plus 5 is just 3x plus 5, because the log and the 10 to the power are inverse functions. Over here, I got 10 to something plus something. That's like 10 to the a plus b is equal to 10 to the a plus, times 10 to the b. Okay? And then that gives me 10 to the log x times 10 to the 4th equals 3x plus 5. 10 to the log x, inverse function property, is just x. So it's x times 10 to the 4th equals 3x plus 5. And if you think about it, that's identical to this equation, except that if you divide both sides by 10 to the 4th, okay? Anyway, I think this is a solution. You can check this. And then if you run through the solution of this equation, you'll see that it gives you the same as a solution. It's the same as a solution of this equation. Okay? If you multiply both sides of this equation by 10 to the 4th, in fact, you get this equation. Okay? And there's a lot there to think about in terms of how things are related, but the first thing you're going to want to do is get those laws into your head and practice with them. Okay? So that's the laws of logarithms and how you can apply them to solving equations.